Great to see you here. My name is Luc de Koster, founder of the Koster Academy, and I'm presenting you a new video related to uncertainty and risk management. One of the things we will use when we are going to look into probabilities and statistical parameters, we're going to look into data and different graphs that may be available. That's very important, and in this video I want to talk more about the data that you will get and the graphs that you may find or use to represent information. But before I continue, don't forget to click on the subscribe button, click on the bell button, and every time we have a new video, YouTube will inform you about it. Let's have a look at data. The data and how do we represent those data. Now, we can get data typically by sampling. We can do the sampling ourselves, and we can use data that have been sampled by other people or organizations. Now, this is very important to understand what is the difference between those data. The data that you collect yourself can be considered as primary data. They always will be the best because you know what you're looking for, and you can use the way to get the data to find exactly the tendencies, the information that you need. Now, when we look at data, and we call those secondary data, these are the data that have been collected and eventually interpreted by other organizations. Now, you're not always sure how these data have been collected, and they may not be 100% what you need. So it's very important if you're using secondary data to find out what the basis of their collection and their interpretation was. Now, in a projectized or a project-oriented organization, you can collect data for further use, and that information will be more interesting, more related to the business you're doing than the other data that you get. So you can collect the primary data, you can use secondary data, but all the projects you do are also a source of data, and you should get that information and get it available, make it available for all the people working on the project. Also, when we have data, we will represent them in different graphs. This is a typical line graph showing some parameters. We have different categories here, different elements that we are considering. We can represent the information in a bar chart where we have the same information in a different format, and we can use it in a pie chart. So these are all different ways to represent your data. Having that information, you can use it to interpret, calculate averages, calculate standard deviations, and so on. And you can share that data and try to find tendencies that you need for your project. The way you represent data is important because if you want to show something to the people, you have to select the data or the graphs that will show them what you want to show them. There are a lot of ways to do that, a lot of programs that are available to represent the data. Now, there are also some problems that can happen. First of all, we have the scale. The scale, if we look at here, the body temperature when we have an expanded scale or a compressed scale. We also looked at percentages. We look at some perspectives that we have, and we can look at the different legends. Now, we have the expanded scale and the compressed scale. Both graphs are exactly the same. The only thing I did was to change the scale on the y-axis. The first graph, we expanded the scale. We go from 34.8 to 38.8, and it looks as if the information, the body temperature is changing a lot. On the other hand, in the graph below, it looks as if everything is stable. So when you look at these things, it is possible to interpret these two graphs completely differently, depending on our knowledge about the graphs. Where do they come from? What is normal? So representing the graph in a specific way will help you to pass over the message, to interpret what is going on. But on the other hand, it can also be used to manipulate or misinterpret the data. We can look at percentages. When you add percentages, you may end up with the effect that the total percentages don't add up to 100. All the elements together, 100. Always. All the data, always 100%. And it can happen when you look at some calculations and some roundings that you end up with a percentage that is different from 100. So here you have to be careful. Perspective, well, how do we look at the graph? How do we represent those different elements relative to each other? And of course, it's very important to add a legend to show what we are really talking about. What are the different informations? What is the information that we share with these typical data? If you don't do that properly, your graphs and your information may be completely worthless. So that was it about data and representations, graphs that we can use. Don't forget to click on the subscribe button, click on the bell button, and every time YouTube will contact you when we have a new video. Thank you very much, and I'm looking forward to seeing you in the next videos. Thank you and bye-bye.